Hi, in this video we will look at a few questions from the topic permutation and combination, and these questions, in order to solve these questions, we need to understand the Fibonacci series, and we will apply this series in solving these questions. So let us start with this Fibonacci series. The name of the series is Fibonacci. Fibonacci is the name of an Italian mathematician. The series is given by him. So the series states that the nth term of the series is the summation of two previous terms in that series, provided n is greater than or equal to 3. This is what the series states. If f1 is equals to 1 and f2 is equals to 2, then f3 is 3, f4 is 5, f5 is 8, which is 3 plus 5, f6 is 13, which is 5 plus 8. So the series is 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. This is the Fibonacci series. Now, let us apply this series in solving questions related to permutation and combination. So, if we apply this series in solving questions related to permutation and combination, the questions can easily be solved without much effort. So let us apply this series. This series is simple. It states that the nth term of the series is summation of two previous terms in that series, provided n is greater than or equal to 3. This is the Fibonacci series. So let us apply this series in solving questions related to permutation and combination. Now let us apply the series in this question. Now this question says that a person can climb a staircase using 1 or 2 steps at a time. So he can use only 1 or 2 steps. He can climb only 1 or 2 steps at a time. In how many ways can he climb? 9 steps. So there are total 9 steps in that staircase using 1 or 2 steps only. Now assume that the staircase has only 1 step. So he can climb it using 1 step. So this is one way. Now if there are 2 steps in that staircase, he can climb this staircase taking 1 step at a time. First he has climbed 1 step and then he has climbed the second step, so he has reached to the top of the staircase. Now he can climb 2 steps at a time because the question allows him. The condition is that person can climb using 1 or 2 steps at a time. So he can climb these 2 steps in 2 ways. Now if there are 3 steps in the staircase, he can climb 1 step at a time, 1 step, 1 step, 1 step. He can climb 2 steps once, 2 steps at a time, and followed by a single step. He can climb 1 step followed by 2 steps. So total there are 3 ways in which he can do. Now look at the way in which this series is going. The first term was 1. The second term was if there are 2 steps, he would have done it in 2 ways. 3 steps in 3 ways. So what is this 3? It is nothing but sum of 2 previous terms. Had there been 4 steps, he would have done it in 5 ways. Now let us check. If there were 4 steps, he would have taken 1 step, 1 step, 1 step. This is one of the way in which he could have climbed those 4 steps. 2, followed by 1 and 1. Now this can be done in, because two identical terms are there, so 3 factorial by 2 factorial. So this is nothing but three ways. Next, followed by 2 plus 2, taking 2 steps at a time. So this is done in one way. So total there are 5 ways. So yes, this is following a Fibonacci series. So had there been one step, the answer would, a number of ways is 1. For 2 steps, the number of ways is 2. So this is the first term of the series, 1, second term, third term, fourth term, fifth term would be 8, then followed by 13, then followed by 21, then followed by 34. This is the fifth term, this is the sixth term, this is the seventh term, this is the eighth term, and had there been 9 steps, it would have been 55. This is the answer. So this is the way we have applied the Fibonacci series and solve this question. Now let us look at another question. Now this question has been modified. In the earlier question, we had only the option of climbing 1 or 2 steps at a time. Now we have the option of climbing 1, 2 or 3 steps at a time. And the total number of steps to climb is 8 steps, using 1 or 2 or 3 steps at a time only. Now, in the similar way, we'll solve this question. If there had been only one step, we would have taken only a single step, and in one way we would have done it. 2 steps, 1 step followed by another step, another 1 step, 2 steps directly, so 2 ways. Now we'll notice the difference here. If there are 3 steps, I can take 1 step, 1 step, 1 step at a time. Now I can take 1 step once and 2 other steps using this, and 2 steps at a time, then 2 steps at once and 1 step at a time. Now I can take 3 steps directly, 3 steps at a time, because the question allows me using 1, 2 or 3 steps. So in total there are 4 ways here. Now had there been 4 steps, 1 step followed by 1 step followed by 1 step, 1 step, I have taken 1 step at a time. This is one way. Next, 2 steps followed by 2 steps, so this is another way. So 2 followed by 1 plus 1, this is another way. So this is nothing but 3 factorial divided, number of ways in which we can do this is 3 factorial divided by 2 factorial, which is nothing but 3 ways. Followed by 3 steps and 1 step. This can be done in 2 ways, because 1 3 and 3 1. Now, so total number of ways is 7 ways. So what was the series that is building up here? 1 followed by 2, then followed by 4, then followed by 7. So let us write it down here. 1 followed by 2 followed by 4 followed by 7. Now if we look at here, 7 is nothing but summation of 3 previous terms, that is 1 comma 2 comma 4. So similarly the next term, that is, this is f1, first term of the series, second term of the series, third term of the series, fourth term of the series, fifth term of the series will be 13, 2 plus 4 plus 7, followed by 24, followed by 44. This is the sixth term, this is the seventh term. Total we have 8 steps. So this would be 68 plus 13, 81. So in 81 ways we could have climbed the 8 steps using 1, 2 or 3 steps only. Next, let us solve another question. The question states that a coin is tossed 10 times. In how many ways exist such that no 2 consecutive heads appear? Now, if the coin is tossed 1 time, I can get a head, I can get a tail. So this is 2 ways. Now if it is tossed 2 times, I can get a head followed by another head, tail followed by another tail, head followed by a tail, tail followed by head. Now the question says that no 2 consecutive heads appear. So this is out of the picture. So this is total 3 ways. Now suppose it is tossed 3 times. So I can get head, head, head. I can get head, head, tail. I can get head, tail, head. I can get tail, head, head. I can get tail, tail, tail. Tail, tail, head. Tail, head, tail. Head followed by 2 tails. Head followed by 2 tails. And so let us check what all the conditions that are not met. So this has 2 consecutive heads, so this won't qualify. This won't qualify. This also won't qualify. This also will not qualify. So in total there are 5 ways. So again here the first term was 2 ways followed by 3 followed by 5. So 2 followed by 3 followed by 5. The next would be followed by 8. Next would be followed by 13. Next 21. Next 34. Next 55. So this is the first term. When the coin was tossed once, tossed twice, tossed 3 times, tossed 4 times, tossed 5 times, tossed 6 times, tossed 7 times, tossed 8 times, tossed 9 times, and tossed 10 times. So the coin had it been tossed 10 times, and in 144 ways we would have in which there would be no 2 consecutive heads. So this is the solution. Now let us look at another question. Now the question states that there is a set A which contains digits from 1 to 10. Now how many subsets of A can be formed with no 2 consecutive elements in the subset? So this is the question. Now let us solve it. assume that there is only one element in the set. So if there is only one element, number of subsets that can be formed are 2, because if there are n elements in the set, number of subsets that can be formed is 2 to the power n. So it has only one element, so there are number of subsets that can be formed is 2. Now had there been two elements in the set, say 1 and 2, this is the set. Number of subsets that can be formed are 4, because 2 to the power 2. Now out of these 4 subsets, one of the subset would be the set itself, that is 1 and 1 comma 2. So we have to subtract it, because the question says that no two consecutive elements should be there in the subset. So I have subtracted that 1 from the total number of subsets. So there will be 3 subsets. Now if there are 3 elements in the set, so this assume that this is the set. So total number of subsets we would have had is 2 to the power 3. It is nothing but 8. So again in this 8, there will be these types of subsets: 1 followed by 2, 2 followed by 3, 1 comma 2 comma 3, that is the whole set itself. So we need to subtract these 3. So 8 minus 3 is 5. Again this particular, we can notice a series. Had there been one element in the series, number of subset with no two consecutive integers in them are 2. Had there been 2 elements in the series, and the number of subsets that contain no two consecutive elements are 3. Had there been 3 terms in the series, the number of subsets that can be formed containing no two consecutive integers is 5. Similarly, had there been 4 terms in the series, it would have been 8 followed by 13 followed by 21 followed by 34 followed by 55 followed by 89 followed by 144. Now this series this set contains 10 elements. So the answer is 144. This is the first term of the series, second term, and the 10th term. The third term is summation of the two previous term. Any term after the third term, which is from the third term onwards, is the summation of two previous terms. This 8 is summation of 3 and 5, and 13 is summation of 5 and 8. The series goes on in this way. This is a Fibonacci series. Let us solve this question. A building has 10 floors. Each floor can be colored using blue or green. So there are 2 colors that are available. One is blue and the other one is green. In how many ways can you color this building such that no 2 floors have same green color? So let us solve this question. So assume that the building has only one floor. So I can color it with blue or green. So I have 2 ways to do it. Now assume that the building has 2 floors. So I can color the first floor with blue followed by second floor with green, first floor with green followed by second floor with blue, both the floors with blue and both the floors with green. However, the condition in the question is that no 2 floors have same green color. So we cannot take this case. So there will be in 3 ways which we can color the building had it had 2 floors. Now assume that the building had 3 floors. So the first floor I will color it with blue followed by green, followed by blue. Now this can be arranged in three ways, 3 factorial ways. 3 factorial divided by 2 factorial, that is nothing but 3 ways. Similarly, I'll start with green in the first floor, blue in the second floor, and followed by green in the third floor. This also can be arranged in 3 ways, that is 3 factorial by 2 factorial ways. However, if we look in depth, so green followed by blue followed by green, this is one case. Then green followed by green followed by blue, this is another case. Blue followed by green followed by green, this is another case. So here there are 2 greens in 2 consecutive floors, and here also the same thing. So we cannot take these 2 cases, we can take only this case. So that's why 3 minus 2, and this is done in one way. Now followed, and that next is I'll color all the 3 floors with blue. So this is one way, and I can color all the 3 floors with green, but again this case we cannot take because no two floors have same green color. Now the total number of ways in which this is done is 5 ways. Now again a series is being developed. The first term is 2 followed by 3 followed by 5. This we are getting 5 as the 5 ways. Had it had 3 floors, so similarly had it had 10 floors, the answer is 144. Now let us check. 8 followed by 13 followed by 21 followed by 34 followed by 55 followed by 89 followed by 144. So first floor had it had only 1 floor, 2 floors, 3 floors, 4 floors, 5 floors, 6 floors, 7 floors, 8 floors, 9 floors, 10 floors. This is the answer. So this is again an application of Fibonacci series. Just make a slight note here. This is no two consecutive floors. Okay. Now let us look at another question. The question states, how many 5-digit numbers can be formed using the digits 1, 2, 3 with no 2 consecutive 2s? Now, had there been assume that there is a single digit number, so we need to form single digit number using these 3 digits 1, 2, 3. Those 3 digits are 1, 2, 3. So I can just put 1 and form a 1-digit number, 2 and form a 2-digit number, and a 1-digit number, and put 3 and to form a 1-digit number. So I can do it in 3 ways. Now assume that there are 2, we need to form a 2-digit number. So 2-digit number, so this can be filled in 3 ways, and this can be filled in 3 ways. It has to be filled using the digits 1, 2, 3. So total there will be 9 ways. However, one such number will be 22, so we should eliminate it, minus 1. So total there are 8 ways for a 2-digit number. Now for a 3-digit number, we have 3 options to fill this place, 3 options to fill this, 3 options to this place, fill this. So we will have 27 such numbers. However, there will be numbers that contain consecutive 2s, 2 to 1. This combination will have 2 such numbers, 3 to 2. This will also have 2 such numbers. Now let us go in depth with this 1, 2, 2. So these 3 numbers can be arranged in 3 ways. So out of which 2 ways would have 2 consecutive 2s, so I have eliminated it. And similarly for 3 to 2 as well, and 222, this is one number which will have all the consecutive 2s. So from 27 we need to subtract 5, so we are getting 22 ways. Now let us look at this series. So what is 22? 22 is nothing but twice of 3 plus 8. That is the third term in the series is twice of first term plus second term. So if there is a 5, if we want to form a 5-digit number using digits 1 2 3, so 3 followed by 8 followed by 22, fourth one will be 60, next this is 82 into 2, this is 144. This is the answer. So in this question we need to form 10-digit numbers using the digits 1 and 2 such that there are no 2 consecutive ones. So let us solve this. So assume that there is only a 1-digit number. So I can form the 1-digit number using the digit 1 or 2. So 2 ways. Now had there been a 2-digit number, you can use 1 twice, followed by 1 2, followed by 2 1, followed by 2 2. These are the 4 2-digit numbers that can be formed. Out of this particular number doesn't qualify because there should not be 2 consecutive ones. So total there are 3 ways. Now had there been 3-digit number, so we can form using this 1 1 2. So this is nothing but 3 factorial divided by 2 factorial, out of which this is 3, but we will have two such numbers where ones are consecutive, so I have subtracted. So total 1 way, followed by 2 1 1, 2 2's followed by 1. So this is 3 factorial ways divided by 2 factorial, so it is 3 ways, followed by 2 2 2. This is another 1 way. So total there are 5 ways. Again this is following a Fibonacci series. Had there been 1-digit number, we can form it in 2 ways: 2-digit 3 ways, 3-digit 5 ways, 4-digit 8 ways, 5-digit 13 ways, 6-digit 21 ways, 7-digit 34 ways, 8-digit 55 ways, 9-digit 89 ways, and 10-digit number is in 144 ways. So that is the question. We need to form the 10-digit numbers. Now let us move on to next question. Next question is as follows. So there is a series of numbers that were given from 1 to 20. We have to 4 numbers should be selected from this set such that they are in arithmetic progression, and moreover the common difference should not be equal to 0. Now if the common difference is equals to 1, so we can take 1 2 3 4, 2 3 4 5, so on till 17 18 19 20. So there are 17 such ways. Now had the common difference been 2, so it is 1 followed by 3 followed by 5 followed by 7. So we can go on in this way: 2 followed by 4 followed by 6 followed by 8, 3 followed by 5 followed by 7 followed by 9, similarly 14 followed by 16 followed by 18 followed by 20. So we'll have 14 such combinations, 14 such sets of numbers that are in arithmetic progression, and the common difference being 2. Now if the common difference is 3, so it is 1 4 7 10 2 5 8 11, so on 11 14 17 20. So there are 11 such ways. So first, if the common difference was 1, 14 such sets can be formed. If the common difference is 2, 14, if the common difference is 1, 17 such sets are formed. If the common difference is 2, 14 such sets are formed. And if the common difference is 3, 11 such sets are formed. If the common difference is 4, 8 such sets are formed, because there is a decrease of 3. So similarly, if the common difference is 5, 5 such sets are formed. If the common difference is 6, then if the common difference is 6, then 2 such. So total number of sets that contain 4 numbers, and those 4 numbers are must be in arithmetic progressions, are 17 plus 14 plus 11 plus 8 plus 5 plus 2. So this is the answer. 17 plus 14, 31, 42, 50, 55, 57. This is the answer. So this is the traditional way of solving this. Now let us look at another way. So there are total 20 numbers, and we need to select 4 numbers from there, and those 4 must be in arithmetic progression. So if we are able to find somehow the first term of this series, first term of this, say 17, 14, 11, 8, the first term is 17. So if we know how this 17 has come, then we can simply, because we are selecting 4 numbers, there will be 3 gaps in those 4 numbers. So we are subtracting 3 from this 17 from the previous term. So we need to know this first term. How is it arrived? So there are 20 terms. We have to select 4, and this 4 will have a gap of 1. So this is how this 17 is evolved. Now once we know 17, so we can easily get the other rest of the series, and we can solve this question. Thank you for listening to